Welcome back to our second video in our exploration of the properties of these trig functions. Today we're going to talk about the domain and range of now the reciprocal trig functions, cosecant, secant, and cotangent. So just like before, how we started off with sine and cosine, we're going to start off this video with secant and cosecant. Just remember that cosecant, and this is where we get a little confusing, you want to say that cosecant is 1 over cosine. It's actually not, it's actually 1 over sine of theta. And then likewise, secant is 1 over cosine. It's a little backwards in that sense. So let's talk just briefly about sine and cosine again. Remember that sine of theta and cosine of theta have the same domain and range. Their domain is, for both of them, is all real numbers. And their range is again from -1 to +1, inclusive. But we're taking a look at the domain and range for cosecant and secant. Well, sorry, let's talk about the domain. Well, remember we have a sort of compound, sorry, excuse me, I had a little brain fart there. We have a bit of a composite function, right? So first off, you input the angle, you find the sine of it, or cosine of it, and then you take the reciprocal of that. So we need to think back here. Well, this is a fraction. Cosecant and secant are fractions. So in this case, this is usually easier to think of what's not in the domain. In the case of a fraction, we'd be asking ourselves what would make us divide by 0. So the question is, really, when is sine of theta equal to 0? For what angles would that happen? Likewise, over here, we want to find out when is cosine of theta equal to 0. Oops, not theta, 0. Alrighty, well, if we take a look back at our unit circle, I'll draw a little one right here. That sine is, again, the y coordinate of whatever angle we're interested in. So that would happen at, well, actually 0 degrees there, or 0 radians. It would also happen right here at pi radians, or 180 degrees. So it would happen for sure when theta equals 0 degrees, or 0 radians. I'm going to just try to get used to using radians here. Pi, and then when I go back to that positive x-axis, which would be at 2 pi. Okay, there's 2 pi there. And then when I go back around over here, which would be at 3 pi. You might be able to see what's happening here is that every multiple of 180 degrees or pi radians, you're going to end up with a y coordinate of 0. Therefore, we can say that any multiple of, or any angle of a multiple of pi, or 180 degrees, is not in the domain. Is not in the domain. Again, the domain of cosecant. And so I would write that like so. Our domain is all thetas, such that theta is not a multiple of pi n. If you want to be really fancy with it, you could write it like this, pi n. Again, n is usually implied to be an integer, but if you want to spell it out for the reader, you could say where n is an element of bold z, that's just a z with an extra line there. Remember that this is just the set of integers, just like the bold r is all real numbers. If we're trying to figure out the domain of secant, well, we need to figure out when is cosine equal to 0. So I'll draw another little unit circle here. Well, that would be when the x coordinate is 0, so that would happen right here. Well, that first angle would be at pi over 2, but it would also happen down here at, let's see, that's pi over 2 plus another 180 degrees, or plus another pi, so that'd be 3 at, bleh, that'd be at 3 pi over 2. Now if we keep going, then we'll be at now 5 pi over 2, and then 7 pi over 2, and so on. And so this happens when theta is equal to pi over 2, or any multiple of pi thereafter. So plus pi n. And so I could write it similarly with a domain of theta is anything, so long as it's not pi over 2 plus any multiple of pi. Any integer multiple of pi, of course. Alright, so let's now talk about the range. And the range is going to be a little funky, but it's not too bad. Remember, the range of sine and cosine is positive, from -1 to +1. Okay, let's think back to the fact that this is a fraction. In general, we'll scooch this over here. In general, you'd start off with some number 1. In this case, right, sine and cosine are 1 over, secant and cosecant are 1 over sine and 1 over cosine. Okay, if I have a small number, and when I say small, I mean close to 0. If I have a small number, the result is a big number. This is general, right? Now, if you take now 1 and divide it by a bigger number, a larger number, your answer is generally going to be a small number in magnitude, right? Magnitude or absolute value. Okay, well, remember that the largest that sine and cosine ever get, again, they're y values, the sine and cosine ever get is 1 or -1 is equal to plus or minus 1. That would translate to then the smallest possible values of secant and cosecant. So the smallest secant slash cosecant, I guess it would technically cosecant and secant, would be equal to 1 over 1 and 1 over -1. Again, I'm talking about smallest in magnitude. So actually, the smallest that secant and cosecant ever get is 1 and -1. Okay, so that's the smallest they ever get in terms of, how, so the smallest in absolute value. So again, smallest in magnitude or smallest in absolute value. We take a look now about the smallest possible sine and cosine. So I'll do this in purple here. The smallest possible sine and cosine, possible value of sine and cosine, is 0, right? Because we've seen both scenarios where sine could equal 0, like sine of 0 is 0 or sine of pi is 0, or where cosine is 0, for example, cosine of pi over 2 or cosine of 3 pi over 2. Those are both 0. Okay, well, if that's the case, then the largest possible secant and cosecant would be 1 over 0. Possible cosecant and secant would equal, well, again, we can't quite do 1 over 0, right, because that's undefined, so that wouldn't quite work. But what if I have 1 divided by a tiny number, right, and tinier and tinier and tinier and tinier numbers? This value is getting only bigger and bigger. In fact, it will eventually get, infinitely big. You get as big as you want. And so actually what happens, and then we could have a tiny negative number or a tiny positive number. So this could be a giant number, which is positive or negative. And so actually for secant and cosecant, their ranges are kind of broken up. Their ranges would be this. And it's hard to talk about them without talking about the graphs, but I want to save the graphs for later. And that the range would be from -infinity to -1. And it could equal -1. And then it jumps, right? We can't get anywhere between -1 and 0. That never happens. Because that would involve 1 being divided by a number greater than 1, which doesn't happen. From 1 up to positive infinity, like that. And that's going to be the range for actually both of them. All right, so sine and cosine, and from sine and cosine we can get the domain and range of secant and cosecant. All right, let's take a couple minutes here to talk about cotangent before we close it up. Remember that cotangent is just 1 over tangent. Well, tangent itself is opposite over adjacent, so the reciprocal of that would be adjacent, over hypotenuse, sorry, not hypotenuse, opposite. Okay, remember on the unit circle here, that would be saying that, well, since the adjacent side would be x, right, this length, the adjacent would be x, and the opposite side here would be y, the opposite side, then the cotangent of this angle would be given by x over y, instead of tangent, which would be y over x. Okay, if that's the case, well, for our domain, the question still ends up being, when is y equal to 0? Because that would involve us dividing by 0, and therefore those values would not be in the domain. Well, remember that y is actually equal to sine of theta. And so we have actually already answered this question. We know that sine of theta is equal to 0 when theta is equal to, again, 0, pi, or any multiple thereof. 2 pi, 3 pi, and so on. And so just like cosecant here, the domain of cotangent is any number other than those multiples of pi. X of theta is not equal to any integer multiple of pi. And likewise, well, for the range, remember that tangent itself is the slope, and so the range of cotangent would be any reciprocal of the slope. Well, if the range on tangent was all real numbers, then the reciprocal of all real numbers is still just all real numbers. I can think of it like this, where on tangent, like this would be a very, very steep slope, so it would be a very large value of tangent. Well, this would be negative, large negative. This would just mean it's a small negative value for cotangent. And eventually, when we get to here, this would be a undefined slope, but kind of the opposite, or the reciprocal of an undefined slope, is actually 0. Right? It'd be flat. And likewise, if the slope was really, really tiny, so this would be a small value of tangent in magnitude again, a small value of tangent, which would mean that the reciprocal of that would actually be very large. And so just like tangent has a range of all real numbers, so does cotangent. So here we have the range and domain of cotangent, as well as cosecant and secant.